Sometimes macro photography is called micro photography, and Nikon tends to do that. Their macro lenses are not called macro lenses, they're called micro lenses. But it's basically the same thing. We're not going to get hung up on semantics today, but basically we're talking about extreme close-up photography when we talk about macro. There's a technical definition for macro photography, and that's where we have a magnification ratio of 1:1. What that means is that the subject you're shooting is life-size on the camera sensor. So if we take a penny, which is 19 millimeters in diameter, and we were to superimpose it onto a full-frame camera sensor, which is 24 millimeters high, we would see that penny life-size on the sensor. This is the classic definition of macro photography, a 1:1 reproduction ratio or higher. So, some lenses are capable of this 1:1 reproduction ratio. We call those macro, or in Nikon's case, micro lenses. And this is where the subject is reproduced life-size on the camera sensor. Other lenses can only reproduce 1:2, meaning the subject is half-size. And some other lenses can actually go higher than 1:1. In this case, this is a 2:1 reproduction ratio. There are some macro lenses out there that can do 5:1. And there's ways to get more than a 1:1 reproduction ratio with a standard macro lens or even a non-macro lens, which we'll talk about. So no discussion about macro would be complete without talking about depth of field. Depth of field is a topic pretty much misunderstood by a lot of people, and I'm going to try and clear it up a little bit. So depth of field is calculated by mathematics. This is the actual formula, and it's a complicated formula, or somewhat complicated, but there are charts. You've undoubtedly seen depth of field charts. They lie. None of them are accurate ever. They can't possibly be accurate. Even though it's a mathematical formula, there is one component of this formula called the circle of confusion, the COC. And this can vary dramatically. And based on what value you plug in for the COC, depth of field comes out completely different. So it's a formula, it's mathematics, but it's not exact. Depth of field is really about acceptable sharpness. What is acceptable? How much sharpness do you find acceptable? And acceptable sharpness is basically influenced by each of our own vision, our perception, and how big we make the image, what the image resolution is, and what the viewing distance is. If let's say we print it, how far away are we looking? The closer you are, the less sharp it is. So when we look at this image, pretty much everything looks sharp. If we look at this one red rock, that red rock definitely looks sharp. That one right there. Well, if we look at that, it looks sharp because, number one, the resolution is low, the display size is low, and the viewing distance, well, doesn't really matter because everything else is low. But in reality, that rock isn't anywhere near sharp, not even close. It's completely out of focus. But yet, it looks sharp when the print is small, when the image is small. So we're talking about acceptable sharpness when we talk about depth of field. It's not an exact science by any stretch of the imagination. What focus stacking does is it combines multiple images, each focused at a different point, to create an image with extended depth of field. It usually takes between 2 and 50 or more images. I mean, you're going to see that I have some with 20 odd images and some far more. And there's a reason for that, and I'll explain that when we get to it. But software combines the sharpest part of each image, and you can do this in Photoshop. Photoshop makes it very easy. It's basically 2 steps in Photoshop. Go to the Edit menu, you choose Align, you go to the Edit menu, you choose Merge or Blend, and that's it. And you can combine as many images as you want. You can also use software like Helicon Focus, which is what I use. Sometimes I just use Photoshop, depends what I'm doing.